So good morning everyone and welcome to today's session. So as I said, we will be covering clustering today, and thanks to Shashi that he has created such a wonderful note that there are no slides today. I will be covering each and every topic from his notes itself, and also I've added some of the few uh, new materials in that which will help you to understand a bit more easily with some visuals and some pictures. So let us start for today. So, uh, so by now all of you must be knowing that clustering is a unsupervised technique. So, any reason for that? Why it is a unsupervised learning? So, anyone, if you want to try, why is it a unsupervised learning, and why rest of the earlier methods that we have done so far was supervised? So mainly the reason being that why others were supervised and here is unsupervised, because here we don't have any historical data. Based on the data set that has been provided to us, we have to make a clear understanding of the data set, and on basis of that we have to make some judgment that in what cluster or in what segment that group should belong to. So it's a kind of self-learning that the program has to do, and on basis of that it has to classify or make some classification. So if you all remember, we did something as KNN, or K nearest neighbor. So on the basis of nearest neighbor, there will be a voting, or in case if it is a regression uh, model, then it will be a average of all the neighbors. So all the neighbors that we have specified, on basis of that, the new out of bag sample will determine that which classification it should go for. So in clustering also, we have something similar concept here, and here what happens is the similar or the nearest group of data set goes into a single group, and one which is more farther away goes into a separate group. So this is the main concept of clustering. So suppose there is an example provided here. Let us understand with an example. Suppose we are head of a rental store and wish to understand the preference of our customer to scale up our business. Is it possible for you to look at the details of each customer, devise a unique business strategy for each one of them? So this is not a definitely a better idea to work with. So what we can do is we can segment our customers into different clusters and mm, target different clusters in a different way. So that will actually help us to come up with a better solution for our all our customers and help us to provide them a better service. So this is one example. And also unsupervised classification, because I said earlier, here we don't have any labeling. And a biggest challenge here in while working with clustering, that you will understand that what would be the number of cluster that we have to group in. That will be a challenge, and how we will deal with it, we will understand it in the code. So here is a simple example of clustering. So here I have a bowl which contains all the fruits put together. Now uh, I don't have any I should say any previous classification or any way to identify that which fruit is banana, which fruit is apple, which fruit is green apple, which is grape, and so on. The only thing I have is how they look like, and what are their features, and what is the content of minerals and vitamins with each of the fruit. So these are the only things that I have. So on basis of that, I can make my data set or my code understand the data set itself and make some classification. So this is an ideal example or how clustering works. In a bowl, I have all the fruits put together. Now, what clustering will do is it will cluster out a red apple into a different cluster, green apple separately, grape, oranges, and banana. This is exactly what clustering does. Let me take one more example. Suppose I have a, a group of many pictures, and in that some pictures contain face, some contains different parts of body like arm, elbow, my knees. So I have these different segments. So what my clustering will do is my clustering will mm, put all the faces together in a separate cluster, all photos of elbow into a different cluster, knees, thigh in a different cluster. So this is what clustering will do, putting all the similar type of data set or feature into a same group. So difference between supervised and unsupervised learning is that we start with a data set, we train that data set, build a model on the training data set, and models like that we did recently, logistic, linear, decision tree, random forest. So one new sample comes in, and on basis of that, we try to classify. So here what is done, suppose if this is a uh, uh, supervised learning. Here I have labeled uh, all of them. I have labeled this as my banana, this is as my orange, and so on. And now if a new fruit comes in, as because my labeling is already done, I will able to classify itself. But here in case of clustering, that labeling is missing. So I have to understand my dataset myself, and on basis of that I have to make a cluster. So that is why there is a self learning involved here. And what happens in an unsupervised learning, that there is no data set, training data that is provided. I have to make an inference in the data set itself and make a conclusion. And there are many examples for clustering, like k-means and other. And on basis of this, uh, I make my classification. So there are various methods for clustering, and there are different types of clustering as well. So mm, these are broad texts that are there, or broad understanding. So mainly in the industry, I have worked with two types of clustering. One is k-means clustering, and another is hierarchical clustering. Most of the time, I have used k-means clustering because it is computationally easy. It takes less time to generate the results, and also visually it is quite good. Not as good as hierarchical clustering, because if you want to explain someone that how it works, hierarchical clustering is quite easy to explain compared to k-mean clustering. So let us get into that and try to understand. So before that, something regarding distance. So we have such many kind of distance measure that we work with. Uh, uh, Here I have mentioned five distance measures, out of which three I have worked with. Squared Euclidean is somewhat same as Euclidean, but only thing is that it has been squared. Uh, Tanimota is something that I have never worked with, and how it calculates, I don't know. Uh, Minkowski distance is also there, but I have not included that. So, any idea what is Euclidean distance, Manhattan distance, and also there was Hamming distance, if you remember, that was for categorical variables that we have done in previous session for KNN. So mainly same type of distance measurement is also done in clustering as well, to calculate how far two groups of cluster are. So as we have done this earlier, Euclidean Manhattan, can anyone explain me how it is, how these are calculated? You can unmute yourself and speak. So regarding cosine distance, if you all remember, you have done something like a dot product and cross product in early days, if you remember. So that is the formula here that we have for a distance calculation. So what happens is, if I have a graph and all my data points are there, so let's say it is like this. So here I have a point and here I have a point, and this is making a angle here with the origin, and let's say this angle is theta. So these 2 points, so there are these 2 points and they are making a distance angle theta. So on basis of this distance, this or this uh, the angle that they are making with the origin, the distance is calculated. This is called the cosine distance. So if you all remember, there was something like dot product and cross product in your earlier days. So if I do it like this, a dot b, it is my dot product. So that will be equal to my mod of a into mod of b into cos theta. So this will be my formula for this dot product, and here I can calculate cos theta using my formula. So for all the vectors I have like I, j, k, cap and so on. Similarly for b also I have, and I can calculate my value of theta, cos theta here. So if my cos theta is nearer to 1, uh, then that means that the angle is very less, or it is making a very less angle, and both the points are quite closer to each other. On contrary, what will happen if cos theta value is nearer to 0, then it is making a quite quite distance apart, and if it goes to -1, then they are 180-degree apart. So in this way cosine distance is calculated. Squared Euclidean distance is same thing, only thing is that it is squared. So now let's come to our k-means clustering and how it is work, how we calculate the value of k. So here we have a simple flow chart to understand that how it works. First of all, we start with uh, our uh, entire data set and we decide a value of k, uh, a random value, or there are some methods to determine the value of k. We will do that uh, in an example. So let us first go with starting that we don't have any value of k, or maybe we can presume that we have a value of k and we will start with it. So input the number of clusters that you have, and after that uh, on a random basis just provide that uh, to or just pick that number of data points from there and provide clusters to all of them. Now with that centroid, calculate the distance of all the new points and then try to decide whether they have been assigned to a proper cluster or not. So sounds a bit complicated, so let me explain with a simple example that how it works. Suppose here I have my data set and these points are distributed like this. So all of a random, what I have done is I have to decide that these points have to be classified into two clusters. So what I have done is at a random 3 points I have given it to one cluster and 2 points I have given it to another cluster at a random. Now I will calculate their mean position. So a mean value for this red one will be stamina. This red one will be somewhere here for red, and for gray one, their main point will be somewhere there. So now try to understand that this 0 is more closer to this than this cross. So is it appropriate that their centroid should be cross, or these 3 points will be should be in the same cluster? Because it seems like this 0 or this point is more nearer to this red dot. So there what I do is, now on the basis of this centroid, I try to calculate my nearest points to this centroid. So the points which are nearest, those are assigned into this cluster. So now my new cluster is, all of them has been assigned this, uh, these 3 points are into a cluster, and now I have calculated its centroid. And now this will shift to here, because this has only 2 points, this will shift here. So this will be the new centroid of my cluster. So this has come into one cluster, and this has come into a different cluster. So in this way my clustering does. And now this process, iteratively it goes on till there is any improvement, or till this centroid moves away from this point. Until and unless there is no improvement or there is no shifting of centroid, my flowchart keeps working. And at the point when I see that there is no improvement and it cannot be uh, improved or changed, this the final thing that I receive is this, and this is how it works. So this is a method of working with k means clustering. It is a quite fast process and works quite well. So any doubt till here? Any difficulty in understanding that how it works? So let us take a example here. Let us take a case study and then try to understand. So here I have my iris dataset, and here I will work with this. And how do we determine the number of clusters, that we will also see. So here in the iris dataset, I have all the features of length of the species, and at the same time there is some classification done for the species, that which species the flower belongs to. So here let me do is, let me take all the data set, or all the numeric part into a data, and the species part into a different. So let me divide my data set, and now what I will do is, I'll try to calculate that what should be my optimum number of clusters. So number of centers, I have made it a dynamic. It will vary from 1 to 15, and within that I will try to predict my within sum of square. So this is within SS is my within sum of square, and for a value where I get optimum within sum of square, I will choose that as my cluster number. Okay, so see, here I have got my within sum of square with my number of clusters. So within sum of square here is quite high. For 2 it goes down, and for 3 it is here. And after 3 you can see it is more or less steady. More or less there is no such significant improvement if I improve my number of clusters. So in this case, what should be my number of clusters? just by a visually just try to explore this graph and try to understand that what should be my number of clusters here. Okay, so no answers. So yeah, so here what will happen is for a value after which it becomes steady, that will be my number of clusters. So here 3 will be my number of clusters. So after 1 there is a steep down, and after 3 it is more or less steady. So 3 is my optimum point here, and 3 will be chosen as my number of clusters. And this method, what we have just done, is called the elbow method. So see if this graph resembles the elbow of a person, and here is the joint. So here is my arm. This is after my shoulder, my biceps, and this is my joint of the elbow. So for that reason, this is called my elbow method. And after a point where I don't see any much change, I will choose that point as my optimum point. So here let us work with k equal to 3. So here in the data set, Setosa has been classified quite well. All 50 has been clustered into a one group number 2. Uh, Versicolor is there is a bit of misclassification. 48 of them are into 3, but 2 of them has been misclassified or clustered into a different group into one. Virginica, there is a lot of mismatch. Most of them into cluster 1, but few of them into cluster 3 as well. So it seems like there is a mismatch, and there is a reason. What could have happened is feature of two flowers might be similar. For that reason, it might have put the cluster differently. So let us make a cross tabulation and also try to understand that how it works. So I think this is a more familiar format when you have done proc frequency or some similar steps in SAS. So if you all can remember this type of format. So here I have a total cross tabulation of, so these are my classes in the original data set, and these are my number of clusters. So cluster number 2, how many information it has? So 50 of them are here. Cluster number 3, how many are here? And cluster number 1, how many? So in this way I have created a total tabulation here, tabulated all my data. So now let me make a comparison between the two graphs, the original one and one after having made the clusters. So let us try to do that. So here if I see first one, as I told earlier, 50 of them has been put into the same cluster. So by cluster, these are same. Both of them are same. Here it is green and here it is red. So few of them are into put into a same cluster, which is okay, which is good. But by species it was only this much, but by cluster it has gone like this. So there is so according to the you know the reference that we had, the clustering has been a bit inappropriate for some of them. Could be possible because the features of two flowers were quite similar, and that is why it was not able to identify or distinguish. But overall, it has worked good. So in previous example, I have made my plot on the basis of petal width and petal length. Here I'm making on sepal width and sepal length, and on basis of that, let me see how much good it is and how bad. So similarly, the same thing. First cluster, each and everything has been appropriately mapped, all of them into the same point, all 50 of them. For this, I see some different points put into different cluster. It should have been, and also there is some uh, points here also which has been put into different clusters. So anyway, so let us now do one thing. Let's make a principal component analysis and let us try to work with that. So what happens in a principal component analysis, uh, if I go here and try to explain. So the information of these four variables will be clustered into one variable, or like that. So uh, the information there I have will be put together in one cluster. So the first cluster or the first variable will have maximum information of these four. Second variable will have less of these two, and third will have even lesser. So principal component analysis I will discuss in detail in next week. So before that, just a quick example that how it works and how we can make use of it. So here I have principal component 1 and principal component 2, and on basis of that, here I'm trying to understand that how well my clustering has worked. So yeah, here also more or less they have the same structure, uh, but only thing there has been some misclustering or similar kind of flowers have been pushed into different clusters. For clustering itself, I have a better package in R. So this is called cluster package. Here I can work with cluster even better. So I don't need to make a principal component of my variables and work with them. So cluster package in R will do it itself. So let us run that and try to work with it. So here if you see these two components, component 1 and component 2 are able to explain 95% of my point variability. So 95% of the information is within principal component 1 and principal component 2, and that is the reason we do principal component analysis, because if we have lot many number of variables and only two variables are not appropriate to represent the entire structure of the data set, then principal component analysis will uh, I would say combine the information of different variables into single one. So these two components will explain 95% of the variability. How it works, how it is, we will come into detail in next class. So here if you see, first cluster was quite well classified or quite well determined, as we have seen that 50 of them has been clustered into the same. So quite good first one, but for the second one we have a bit of mis classification, or they have been put into a different cluster. Otherwise this looks good. So any doubt till here, any issues or any difficulty in understanding? Okay, so all good till now. Good then, so we will move to our next topic. Not next topic, so our next data set that we have chosen for today, that is protein consumption. So let us try to see here how it goes. So here I have my data set, food. So this data set is not quite big. It has only 25 uh, observations, 25 rows. And here what happens is, these are type of food: red meat, white meat, egg, milk, fish, cereals, starch, nuts, and fresh vegetables. So this is mainly tracking of protein consumption of a individual in these countries. So what are the protein consumption that a person has in country Albania, and what are the sources? So these many amount of protein comes from red meat, from white meat, from egg, and so on and so forth. So this is a kind of data set that we have, and we need to cluster similar countries together. So a country where eating habits are quite similar, or the protein consumption, uh, I would say, pattern is a bit similar, I need to cluster all those countries into a single one and others into different clusters. So let us try to work with this and try to understand that how we can do that. So first of all, let us try and make some prediction only on the basis of red meat and white meat. So here also, if I see, red meat and white meat has quite high number, though milk and cereals also has a quite high source of protein, far more than red meat. But for the time being, let us only work with red meat and white meat and try to cluster them on this basis. So here I have made the clusters and now let me order them. So if you see, here are only three clusters that I have made. First of all, I have not made or I have not made any evaluation on the elbow method till now. So only just looking at the data, I thought of making it like this. So this is what I have achieved, and this has been sorted according to the number of clusters. So one comes, then two, then three. So let us now try to plot this and try to understand that how it has been clustered. So here if you see, countries like Switzerland, Ireland, Belgium, France and UK are into one cluster, and countries like Poland, Denmark, Czechoslovakia, East Germany, Hungary, Austria, Netherlands, West Germany are into different clusters, and rest are in this other cluster. So this is how clustering has worked, and this is only on the basis of two variables, white meat and red meat. So let us try to understand that what I have done in the code. So in the first thing, what I have done is I made a plot on the basis of red meat and white meat, x and y axis, and type equal to n. Type equal to n means it will not plot anything. It will remain as blank. And I have specified my x limit and y limit. I have set my x label and y label. And now what I'm doing is, on the basis of this plot, as because I have not printed anything, uh, I have made my x-axis and y-axis defined, and labeling here I am putting as country. So the name of the country I am putting it here, and the color that is provided, that is on the basis of cluster. So group made cluster plus one. So plus one means that it will be colored accordingly. So if I remove plus one, so the color will change a bit. Let me show you. So now color has changed. So every color, or I would say, yeah, every color has a number associated with that. So if you have a numeric variable, you can define it as your color, and color will change accordingly when the number changes. So this is my result. So let us now try to do that again on the entire data set, and let us try to predict what will happen. So let us make some analysis also on the basis of elbow method and try to see if we can come up with optimum number of cluster here. So here if you see, I don't get a as steep as it was there in my previous data set that was for iris. Here also 1 2 here it is going down, and after this point maybe after 5 more or less it is steady. 3 also is a good, but most of the variance as explained here, uh, so after that it is more or less steady, but I can either take 3 or 5. Okay, so let us now try to work with 5 and try to understand that how my results will be. So one thing, if I, so, so here 4 looks better option, 2 3, and then 4 or 3 looks a better option. Let's work with 4 only, try to see, because an even number of uh, rows are quite less, so we have only 25 observation, so making the cluster points quite high won't be a good option to work with. So let us work with 5 only, and let's see what will be the results. So yeah, n start is one of the feature that so if you remember here, what we have done is we have assigned to the entire data set. So n start, what it will do is it will assign only to the first 10 variables. So if suppose I have specified that n start equal to 10, then it will start with 10, not all of them, start with 10. So to make a better elbow graph, it is advised that you specify your n start, otherwise your n start value will always be 1. So always try to specify n start depending upon the number of observation you have. Uh, Ideally, uh, because here number of observation was quite less, so I have started with n start equal to 10. Otherwise, n start equal to 25 or 30, if you take, that is advisable to take for a bigger data set. So let us now make a plot and try to understand. So here if you see, all of these are into different cluster. Here I have. So one thing here happens is making a I'm making this what should I say, this plot only on the basis of these two variables, red meat and white meat, not on the basis of other variables, and that is why I can see that uh, few of them has been overlapping. So there is overlap between uh, two cluster points. So it is not true actually. What happens is these two does not define all the variation that I have. These two define only the part of variation. So let's say if I change my uh, one of the axis to other axis, let's say if I change it to cereals, because I can also see that cereals has high number of protein, it can define my variation in a bit more better way. So let us do that and try to understand the basis of cereals here also. And let me change this Y label from white meat to cereals. So here if you see, now my clustering looks more appropriate. Why? Because cereals is able to explain the variation better than white meat. So I have plotted only between cereals and red meat, and now see it has improved by a good margin, my cluster plot. So yeah. So any questions still here?
Yeah, Ankit,
Yeah.
I have one doubt.
Tell me.
So, so in the figure, I saw one thing.
Mm-hmm.
So maybe there is a blue, Finland, Norway,
Mm-hmm.
and these are overlapped. They are overlapped with the Austria.
Mm-hmm.
So, but according to K-mean,
Mm-hmm.
so K-mean have some theory about there is a minimum inner distance between the clustering and the maximum distance between the two different clustering according
Mm-hmm.
to the K-mean.
Yeah, correct.
So yeah, so my view maybe these are the not accurate clustering because of that these are overlapped with the different clusters.
No, so what you're saying, I got that. So you're saying that these are overlapping and it should not be appropriately done like this. But what happened
Yeah.
is, because, see, I made my clustering on the basis of, where it went. So on the basis of all the variables, like starting from red meat, white meat, eggs, and till fresh vegetables. And I have made a plot only on the basis of two variables. So would you think that these two variables will contain the variability or the variance of all the variables? Will it define all the qualities of all the variables? I have taken these two variables because these are more, I think, more contributing than other variables, and that is the only reason I've taken this. And my clustering here is plotted only on the basis of these two clusters. In case if I have made a principal component analysis here and then made a plot, then it would have been a bit different. But the reason being, I have only taken these two. It has a bit of overlap, so that is the only reason you can see a overlap, not because it is a, um, clustering error is there.
Okay.
Okay. Yeah, this question is quite valid because in two-dimensional it seems like that my clustering hasn't worked well. But here, if you see the number of variables that I have to make a plot of seven-dimensional or six-dimension. Then I will get a appropriate plotting. So that liberty I don't have. What I could have done is I could have made a principal component analysis and then could have shown you the graph. So let us proceed to one more data set that we have on K-means clustering, and let us try to work with it here. So here in this data set, uh, if I view this, So here I have around some 400 observation and my states. So all the states of USA, there are my column, and here in the rows I have unemployment rate. So unemployment rate in the first month, second month, third month, and so on and so forth. So these are my states, and these are my unemployment rate for them. And now what I want to do is I want to cluster all my um, states which have similar sort of unemployment rates into one cluster and others into similar. So this is what I want to do. So let us try to do that using k-means again. So here I have all my states mentioned and their unemployment rate. So let us try to make a plot for that and try to understand how it will work. So here I have unemployment rate. So first is for the black one is for California. Second, this red one is for New York, and this third one is for Iowa. So these are my this is a typical time series graph that you see. So we will cover this how a time series graph look like. So this is how it has been plotted. So let us do some analysis more and try to make that. One more thing, I have all my uh, should I say, this states as my column name. I want to transpose it and put it into as here my row name, so that I can make a proper cluster of all of them. So let's make a transpose, and now let us work with it. So in R we have a simple uh, syntax T of raw data. So T of data will transpose it. So here now let us start with two clusters and try to see how it goes. So in the two clusters, it has done something like this. It has either divided in so so first cluster has 23 and second cluster has 27. So this is how it has done. Let us try with some more and try to understand. So now it has clustered it like this: 1, 2, and 3, and then 1, 2, 3, and 4. Uh, 1, 2, 3, 4, and 5. So after a certain point, it doesn't make much sense to increase the number of clusters. So what I have done is now I have taken a mean and standard deviation of my unemployment rate. So here in the data set, after making this transformation, I have calculated the mean of all this of a particular state, mean of all the unemployment rate, and standard deviation of unemployment rate, and I have put that into a different column for all the states. And now let us try to make a cluster on it and try to understand how it works. So here I have only mean and standard deviation, and here I have state name. So now with center equal to 3, let us start and work with it. So here One with higher mean and standard deviation are put into a different cluster. One with lesser are put into a different cluster, and here all of these are in different cluster. Here what also I could have done is these also seems like are part of a different cluster because these values are quite low, and there could have been also separation here as well. So I could have, and also these two are quite extreme points. So even a number of clusters 5 would have uh, worked well here. Whether I could have put this and this one into a different cluster. So if I try with 5, so say now it has taken some other pattern because that pattern we cannot restrict. It depends upon the k-mean itself. But yeah, these of the kind. So what I was trying to say is that these points were uh, expected to be uh, quite far away and should have been a different cluster. So it has put them together. This together. There I have, and here also these two into different. These four I thought to be different, but here centroid point was quite nearer or somewhere here, so it was more closer for this cluster. This could be a you know a kind of state or a point which could have been closer to either of the two. But ultimately, it went with this. So this is how mainly a K-means clustering works. So any doubt, any issue still here? Any questions? Okay then. So let us go through some text of hierarchical clustering, and we will take some examples for that, and let's see. So here K means I hope all of you have understand and observed that how it works. In hierarchical clustering, it is much similar to a decision tree. The way a decision tree works, it is more or less in a similar way. There is a bit of difference between, but more or less the kind of method or the approach that we have is somewhat same. And also, when you try to explain someone hierarchical clustering, it is much easier to explain rather than k-means clustering. So you have to understand things like kind of distances that we have, how this distance is calculated, and so on. So these are those challenges to explain are not there in hierarchical. It is a bit more simple. Only problem is that with hierarchical clustering, it's calculation wise, it is much more time consuming. So we have mentioned that in the uh, s- material as well, that k means for k means it is directly proportional to n being my number of samples, and for hierarchical clustering it is proportional to n square. So let us go through hierarchical clustering and try to understand there. So here I have a tree-like structures or called dendrogram is built. Every cluster node contains child cluster, sibling cluster partition, the point covered with their parent uh, common parent. So here what happens is I start with a main data set and it is further clustered into my samples, and then towards the end I put them together into a cluster. So at the end I find the pair of closest pair of cluster and merge them into a single cluster, calculate the distance between the newer cluster and each of old cluster. We repeat this step until we reach into a k number of clusters. So here I have two types of clusters. The approach that I have is bottom to up and top to down. Bottom to up means I start with all my sample points, all my data points, and then move up. And top down is I start with my data set, entire data set, and move down to sample points, each of the points. And here, good thing about hierarchical clustering, if suppose I want to decide that I have to restrict it somewhere, what I can do is I can draw a line here. I feel that after going even below this doesn't make sense. I can restrict myself here and I can declare that all these partition are making my number of clusters and they should be put in. So after this, anything which further splits into a separate single cluster, into a single cluster, and so on. So this is the liberty that I have here in hierarchical clustering. So let us understand the bottom up and top down algorithm. So algorithmic hierarchical clustering is a bottom up clustering method where clustering have subclusters which in turn have subclusters. It starts by letting each object uh, form its own cluster. So from all the samples to another cluster, then another cluster, and so on till the entire data set. And it repeatedly merge cluster into larger cluster and larger cluster until all the objects are into single cluster or certain termination condition is satisfied. The single cluster becomes hierarchical root. That is the root here at the top one. So by that time, all the dataset has merged together. For the merging step, it finds two clusters are closest to each other and combines the two to form one cluster. So this is the bottom up method. From all the nodal points or the terminal points, I reach to the entire or the big cluster or all of them set together. Now in the decisive method, I start with my entire data set and reach down to each of my sample points. A top-down clustering method is less commonly used. It works in similar way to algorithmic clustering but in opposite direction. This method starts with single cluster containing all the objects. From top, I have all the objects set together and then successively splits resulting cluster until uh, until only clusters of individual objects remain. So all the sample points till the very end. Decisive clustering. So it is a top-bottom clustering method which works in a similar way to algorithmic clustering but in opposite. I think which is same thing and repeated. This method starts with a single cluster containing all the objects and then successively splits. I think yeah, same thing has been repeated. So anyway, so there are few advantages and disadvantages. Let us take one example of hierarchical clustering and then let us come back here. So here I am taking my data set as empty cars and we will run the clustering method here. So so here in the row name I have my car and miles per gallon, number of cylinders, uh, displacement horsepower, so and so. So let us work with this and let us see how we can cluster these cars together. So here what I've done is I've already decided that my k equal to 5. So on basis of this, it has made a rectangular hierarchical clustering. So first of all, I've calculated the distance between all the rows or all the variables that are there, and based on this distance, I have plotted hierarchical clustering. And then accordingly, I have made a plot of this cluster, and then a cluster denote or I have denoted a cluster number, and on basis of this, a box or grouping all of them together. So here if you see, as I said earlier, in this hierarchical clustering, I have that liberty to put all of them together. So here I can decide that this will be my size of the tree, and after this all will be into the single cluster. So on. So like this. So anything below this point will come into my cluster. So this liberty is there with me. Now suppose if I change a bit and put it to a number of cluster 3, then you see that size of the tree has reduced even further. That height has gone down. So first of all, it was making a segment here. Now it is making a segment here. That after this split, I will decide that whether it will come into a single cluster or not. So hope it makes sense now. So let us go through few of the advantages and disadvantages here. So one of the most common advantage that we had here is that it was easy to explain or easy to visualize rather than my k-means clustering. So here I've just drawn a chart, and on basis of this I was able to understand and to decide what will be the height of my cluster diagram. And also on basis of this I have decided that what will be my cluster would be. Much easy to explain, much easy to understand and to visualize. And also I can change the number of clustering towards the end. I don't need to specify my number of clustering at the beginning. Here I have first drawn my cluster dendrogram, and after that I can change my number of cluster. So this liberty I have here in hierarchical clustering. I did not specify my number of cluster towards the start, right? So these are the main thing that we have. And also one more issue was with that came in was there and not with hierarchical clustering, that I can explain it only on the basis of two variables. If I have a 2D graph, I can explain it only on the basis of a 2D, and if I have a 3D, only till that extent. Otherwise I have to make a principal component analysis, and then I have to put it into a graph then to visualize. But in hierarchical clustering, that visualization was not an issue. So let us go through some of the differences between them. In hierarchical clustering, uh, can't handle big data well. K-means clustering can. The reason being, K-means clustering is calculatively take less time compared to hierarchical clustering. In K-means clustering, since we start with random choice of cluster, the results produced by running the algorithm multiple times might differ. Yeah, it is a issue. So that is why it is always recommended, if you want to have the same result every time, start with a seed, set.seed. So here in the set, what I have done is for every time when I have run the K means clustering. If I have set a seed. So if you set a seed, that results will be generated in the same way every time. So set.seed is an option. If you don't specify that, then the results might be different in different iteration. But in case of hierarchical clustering, that is not an issue. K-means is found to work well when the shape of the cluster is hyperspherical, like 2D or 3D. Yeah, because if it is an elliptical, then it also might get into another cluster, like we have done here. First of all, we were expecting this to be in this cluster, but somehow that the cluster orientation was not quite spherical, or maybe due to some other reason, it has gone into this cluster, not into this cluster. So that is also an issue with this. And prior knowledge of the value of k should be there in k-means clustering, but that is not an issue with hierarchical clustering. And that is the best liberty that we have when we work with hierarchical clustering. So this is all. Here we have some cluster benefits and some limitations. So these are just for general purpose, and I also have made some uh, introduction or examples in the beginning as well, where it can be used and how it can be used. So this is it from my side. So anything else that you have as a question or you want to ask? So thanks everyone for attending the session, uh, and thanks for being along. So next week I will be coming with PCA and support vector machine. So we will work, and after that we will have one more week of sessions. So that is all from my side. Thanks everyone for joining in. See you next week.